Hello class, welcome to SciChem. Today we are going to discuss about kinetics of base catalyst. In the previous class we have discussed about kinetics of enzyme catalysis. Now we are going to discuss about kinetics of acid base catalysis. Any reaction in solution phase catalyzed by acid or base, that reaction called base catalyzed. And this reaction can be carried out in two steps. Let's consider mechanism 1. In this mechanism 1, here first step includes the substrate reacts with acid to form H plus minus. Here the substrate reacts with acid to form SH plus, that means SH plus is the protonated substrate, which is called protonated substrate. And in second step, SH plus will react with water to form product is. So here the substrate will accept a proton to form protonated substrate, and this protonated substrate undergoes reaction with water to form product and H2O plus ion, and this is the mechanism 1. So here I can assume this K1 for forward reaction, K2 for backward reaction, and this is K3 second. As well as it is a first reaction, it is a so I need to calculate rate of a reaction of acid base catalysis. So for this reaction, rate of reaction, I can simply write dP by dt, and it will be equal to K3. So this is the rate of reaction. Since SH plus is an intermediate and it comes in three reactions, forward, backward and this reaction. So here by applying SSA, I can write dSH plus dt. So dSH plus by dt equal to 0 equal to total change in concentration in all three reactions, because SH plus, here the SH plus is involved in SH plus, so forward, backward and this reaction. So total change in concentration I can write. For forward reaction it is K1S to HA, and for backward reaction I can write K2 H plus minus, and for this reaction, since here it is the reactant, I can write K3 H. So here 0 K1 SH, I can take SH plus H common, minus K2 A minus plus K3 . So from this I can easily calculate the value of H plus. So H plus is equal to K1S into HA divided by K2 so consider this is our equation 1, and by applying the value of SH plus in equation 1 can get rate of reaction is equal to K3 and K1 minus K3. So this is the rate of acid base catalyzed reaction for mechanism. Another important concept is there, since here A minus is the conjugate base already studied in ionic equilibrium. J, these are weak acid, because in enzymology or the reaction which is catalyzed by acid or base, generally we have to take organic acid, and generally organic acids are weak acid. So here the dissociation constant Ka will be equal to molar concentration of H plus into molar concentration of A minus divided by, so the concentration of A minus will equal to Ka to Ha so you have to note this, we can use this later. So there are two cases arises. Case 1, when K2 is very greater than 3. That means what is our reaction? This is our reaction S plus Ha raised to H plus again gives rise to is our K1. If K2 is very greater than K3, means the reaction will move toward backward direction. So if K2 is very greater than K3, that means K3 is negligible. So our rate will be rate is equal to K3 K1 S A divided by K2, and this A minus can be replaced by this amount. So rate will be equal to K3 K1 A divided by K2 multiplied by Ka A divided by, so Ha cancel each other, so I have K1 divided by K2 Ka multiplied by, so this whole I can take another constant dash. So when K2 is very greater than K3, then get equal to K dash. So here rate directly proportional to concentration of plus more is the concentration, and then the reaction will move toward backward direction. Then another case is there, case 2, if K3 is very greater than K2. If K3 is very greater than K3 is very greater than K2. So this, so if K3 is very greater than K2, then the reaction will move forward. Then the reaction will move forward. And here K2A minus can be neglected. So I can simply write of reaction equal to K3 K1 K3 this tends to 0 because K2 is very small. K3 cancel out of reaction equal to K1 so this is our rate when K3 is greater than K2, and when K2 is greater than K3, this is our rate. So this is and this reaction is catalyzed by proton only, so this is called specific acid catalyzed, and this reaction is catalyzed by acid only, it's called general acid catalyzed reaction. So we have completed the mechanism 1. The mechanism 1 involves a substrate reacts with acid to form proton substrate complex, and the proton substrate complex will react with water to form product and gives H3O plus ion. So we have to calculate the rate, and the rate will be dP by dt is equal to K3 into SH plus. So here we have to calculate SH plus, and we have two cases, if K3 greater than K2 and K2 is then. So we have another mechanism, what happens here, the substrate first reacts with A form H plus A minus, and in the second step the substrate protonated substrate complex again reacts with minus form product this is okay. Plus HA A1 so what happens, we have to assume that in the second step the acid forms of the substrate react with base A minus instead of what in the previous case the protonated complex or protonated substrate is going to react with water, but here the protonated substrate is reacts with the base A minus. So here again we have to calculate rate of reaction, and rate of reaction equal to dP by dt, and it will be equal to A3 so we have to calculate the concentration of SH plus same by applying steady state approximation, right? dP by dt equal to 0, and it will be equal to A1 S A minus A2 minus A3 so here K1 A take minus common A2 A minus plus K3 so to take A minus A2 K2 plus K3 H plus so here to calculate concentration of SH plus, and it will be equal to K1 A divided by 2 by putting this SH plus value in this equation. So right, rate of reaction is equal to 1 A So this is our rate of reaction or kinetics of substrate base analysis. Thank you. And this is the last class of surface chemistry.